Hi everyone, this is Cyrus from AIML and my topic is page replacements algorithms. Page replacement algorithms. What is page fault and when does it occurs? Before going to topic, what is page fault and when does it occurs? When the page requested by a program is not available in the memory, it is called a page fault. Whenever we want to execute some program, if the data is not there in this main memory, we have to request the main data from the main memory and we have to request the data from the secondary memory into the main memory to execute that program. Otherwise it may occur the page fault. This usually results in the application being shut down. What is page fault? The main functions of page fault paging are performed when a program tries to access page that are not currently mapped to physical memory. This situation is known as a page fault. Whenever we want to execute one program, if the data is not present in the main memory, that situation is called the page fault. This operating system must then take control and handle the page fault in a manner invisible to the program. Therefore, the operating system must determine the location of the data in secondary storage, obtain an empty page frame in RAM to use a container for the data, load the requested data in the available page frame, update the page table to show the new data. A page table is the data structure used by a virtual memory system in the computer system to store the mapping between virtual addressing and physical address. Virtual addresses are those unique to accessing process. The physical addresses are those unique to the hardware, that is RAM. The overview of this para is whenever the page fault is occur, the operating system will handle that page fault. How it is handled means it will set the location of the data in the secondary memory and this transferring from the second memory to the main memory, then the process is the program is executed. What is page replacement? When memory located in the second memory is needed, it can be retrieved back to the main memory. The process of storing the data from main memory to secondary memory or swapping out, retrieving data back to the main memory and swapping in. Whatever this transferring from the secondary memory to main memory is called the page replacement. This is called the page replacement. If the process of storing data from, if the process of store data process from main memory to second memory, then we will call it as a swapping out. If we and back to main memory from second memory to main memory, it is called swapping in. Why we need a page replacement algorithm? The main goal of page replacement algorithm is to avoid the lowest page fault rate. The main reason for this page replacement is to avoid the page fault. Here one flowchart is there. See here. Start. Send page request. Page found. If the page is found, it is called hit bit. If there is no page is not found in that main memory, we will go to the second memory to set that memory. That is called the fault here. And the fetch page from the second memory, and we will stop and then we will execute that process. Here mainly there are 5 types here. Types of page replacement algorithms are first in first out, that is called FIFO, optimal, least recently used, least frequently used, most frequently used. Here we mainly will discuss these three. This is first FIFO and optimal and least recently used. First go with first in first out. Different string is, for example, this is the string that is 1 comma 2 comma 3 comma 4 comma 1 comma 2 comma 5 1 2 3 4 5. For example, if we take the 3 frame main memories, then how it will work? Once we'll see one example here. FIFO example. First, this one page is entered into this frame. Again, this 2 is entered into the next frame, and this again the 3 is entered into the third frame. Until here, until 3 we don't have any problem here. Then there are 3 page faults occur in this. 1 2 3. There are 3 page faults occur here. And next Next, the 4 has to be entered into this page, this frame to execute that 4. So we have to replace 1 from this 3 to execute the 4. As we have this FIFO rule, that is first in, first out. The first in is this 1. So we have to replace this 1 with the 4. Here you can see the oldest one. That means here the FIFO, first in, first out is 1. So we will replace this 1 with this 4. And the another page fault is occurred with this 4. There are 4 page faults occur until here. Next is 1. What we have to replace the 2 here. Why? Because this is the first in, first out. With comparing this 4 and 3, 2 is the first in, first out. So we have to replace this 1 with this 2. Next 2. The page faults are here 5. Next, we have to replace these 2 with some either with 4, 1, 3. But we have the FIFO rule, first in, first out. The compared with this 3 is the first in, first out. This is the 3 is the first in, first out. So we have to replace the 3 with the this 2. We have completed up to 2 here. Next, that is 5. 5. We have to replace 5 with one of these 3. So according to FIFO rule, we have to replace the first in, first out. So 4 is the first in, first out. Oldest one is the 4. So we replace this 4 with this 5. Next is 1. As we have 1 in this frame, we no need to execute again. So this is called the hit bit. We will call this is hit bit. Here we determine in this green color. So this is mean hit bit. Next 2. We have to execute 2. But the 2 is already there in this main memory frame. So again the hit bit is occurred. And next we have to execute this 3. So we have to follow the FIFO rule. According to the FIFO rule, we have to replace this 1 because 1 is the oldest one, that is first in, first out. So we have to replace this 1 here, and again one fault is added in these page faults. So next we have to execute the 4, and 4 is replaced with this 2 because according to FIFO rule, the 4 is replaced with these 2, and again one page fault is occurred and we'll add it into this list. And next 5, as 5 is already there in this frame, so 5 is hit bit. Here you can see 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 page faults is occurred. Here you can see 1, 2, 3. 3 hit bits are occurred in this example. The first, as you know, this first in, first out mean first whatever the process is entered into this frame, that has to be executed first, and it has to be retrieved. It has to be go out first time. Here, next algorithm is optimal replacement algorithm. Well, simply it is called as OPT. And here one example is given. So with one example with 3 frames, main memory 1. Here 1 is entered into the first frame and one page fault is occurred, and 2 is entered into the second frame and another page fault is occurred, and 3 is entered into the third frame and another page fault is occurred. Until here we don't have any problem. So we have to next replace one of these 3 with the next, that is 4. So in this optimal, we have to choose which has to be used for longer time. Here 3 is used, 3 will be used after this 1 and 2. Next coming processes, 3 will be used after this 1 and 2. Here you can see 1 is there next to this 4 and 2 is there next to this one, but 3 is there far away from this. So we have to replace which will be used for longer time. So we will replace this 3 with this 4, and the 4 is entered into these frames and another page fault is occurred. Here next is 1. 1 is already there, so it is hit bit. Next to 2. 2 is present in the table, so hit is the page. Next to 5. We have to replace this one. We have to replace one of these 1, 2, 4 with this 5. So we know optimal means which will be used for longer time. Comparing with these 3, 1 is used next to this 5 and 2 will be used next to this 1, but 4 is there after the 3, so it will be used for long. It will be used after this 1 and 2, so we have to replace this 4 with this 5, and another page fault is occurred. And 1 next to 1, as we have already there in the frame, so 1 is the hit bit. And next to is 2. 2 is also there in this frame, so 2 is also a hit bit. Next 3, we have to replace these 3 with one of these 3, 1, 2, 5. Here if you check in this list, 4 and 5 is there next to the next after the 4. 2 is there, 2 is not there here, but 1 is there. Here we have the problem. We have to replace this with the first in first out, which is entered first. 1 is entered first, so here we have to use first in first out. So 3 is replaced with this 1. Next is 4. 4 is replaced with either 3 or 5. So here there is here 5 we should not replace, because next to this 4 only we have to replace either with this 3 or 2, but we have to check which is the first in first out. 2 is the first in first out, so we have to replace this 4 with this 2. Next is 5, as 5 is there already in the frame, so it is the hit bit. Here totally how many hit bits are there? 1, 2, 3, 4, 5. There are 5 hit bits are there, and 1, 2, 3, 4, 5, 6, 7. 7 page faults are occurred in this example. Total page faults are 7. And next example is least recently used. Least recent, here you can see with one example, with here the example with 4 frame main memory. First 1 is entered into the first frame, no problem. 2 is entered into the second frame, and the 3 is entered into the third frame. There are 3 page faults occurred till now, and the 4 is entered into the fourth frame, and the 4 page faults is occurred till now. So next one we have to execute this one, as 1 is already there in this frame, so it is hit bit. It hit the pages. And next to 2 is also there in this main frame, so 2 is also the hit bit. And here least recently used, what is meant by least recently used means which will be used for longer time, which will not be used for longer time. Here comparing, here we have to replace this 5 with one of these 3, one of these 4. So here with one example I will tell. Here 1 is used recently, 2 is used recently, and 4 is also used recently compared to these 3. So 3 is not used for more time, so we have to replace this 3 with this 5. Yes, here 3 is replaced with this 5, and another frame, another page fault is occurred, that is 5. And next 1 is already there in this main frame, and it is called the hit bit. And next is 2 is also there in this frame, so it is hit bit. Next we have to replace this 3 with one of these 4. Here you can see, compare, 1 is recently used, 2 is recently used, 5 is also recently used, but 4, comparing with this 1, 2, 5, 4 is used very longer time. So least recently used. It is used recently. For least recently used is 4. So we have to replace these 3 value with this 4. And next 4, we have to replace the 4. Comparing, we have to compare with this 4. 1 is recently used and 2 is also recently used. 5 and 3 is also recently used. Comparing with this 3, 5 is used very recently. Is used very recently. So we have to replace this 4 with this 5 with 4. Here you can see 1 is most recently used. Here 1 is most recently used. So it is the recently used is 5. So we have to replace this 5 with this 4. Next, we have to replace this 5. And here you can see compare 1, 2, 4, 3. 1, 2, 4, 3 is there. And we have to replace one of these 4 with this 5. Comparing with 2, 3, 4. 1 is recently used. So 5 is replaced with 1. There are 1, 2, 3, 4, 5, 6, 7, 8. 8 page faults is occurred in this, and 1, 2, 3, 4. 4 hit bits are occurred in this least recently used example. Here you can see 8 page faults are occurred, and 1, 2, 3, 4. 4 hit bits are occurred. Thank you.